Thank you, Dr. Sundaram. First of all, I congratulate Professor T.T. Sundaram and also congratulate and also appreciate because this is a second FDP in 2 consecutive years under ATAL format of AICTE. On behalf of Adiman College of Engineering, Principal Management and Department of Chemistry, I am Dr. Shivakumar. I am very happy to welcome all scientists, professors from the various domains of this Indian nation. First, I welcome Dr. C. Suresh, a senior scientist, EEC Division Secretary. I give a little bit short introduction about our today's speaker. He started his college education from BSc Chemistry in Government Arts College, Periyar University, Salem. I'm very happy to share. Dr. Suresh is my senior, and he completed his postgraduate in Guru Nanak College, University of Madras, Chennai. After finishing his postgraduate studies, he moves to Anna University, Gindi campus for pursuing his PhD under the guideship of Dr. Shanti Madam. Then moved to Mexico, California for postdoctoral research in Central D Nanosciences. His area of expertise is the development of electrochemical sensor and biosensors for environmental and biological application, structural activity relations studies of oxygen reduction, hydrogen, and oxygen evolution electrocatalysis, and 2D metal chalcogenates and nanoporous material for multifunctional applications, heterogeneous catalysis development for conversion of crude oil and biomass to value-added chemical and energy generation. Under research, now current project is the investigation of molybdenum sulfide 3D ordered mesoporous carbon nanocomposite electrode for energy-related environmental application. Awards and achievements. He received he is a GATE qualifier in the year 2005 and Mexican government leading postdoctoral fellowship during the year 2013, a national investigator level from Conosite SNI Mexico during 2013, and worked as a senior CONCAT postdoctoral fellow during 2013. With this short information, I welcome Dr. Suresh for this ATAL faculty development program to give their valuable inputs towards somewhat advanced nanomaterial sensor based sensor for monitoring the health and environment applications. I welcome you, sir.
Yes, thank you, Dr. Shivakumar.
Sir.
Thank you, Dr. Sundaram. So, very good evening to all the participants, those present in the particular program. First of all, as Dr. Shivakumar and Dr. Sundaram mentioned, so today I just want to give the overview of what are all the advanced functional nanomaterials which has been used for sensing of our healthcare as well as the environmental monitorings. So this talk mainly focuses on the overview of different type of materials, advanced material, and its functionalization for sensing of a particular analyte molecules. The analyte, it may be a biomolecules if we want to sense our healthcare, or in some cases it may be a environmental molecules. This is the overview, and also I want to thank the entire team of Adiman Engineering College and Management for giving the opportunity to present my present research area as well as the work what we are doing in SICRI under electronics and electrocatalysis divisions. So hope this entire 2 hours period you will have some idea about the new materials and new applications for sensing, only on the sensing of different molecules. So with this, I will start today the classes with the starting point of nanomaterials. So this is everybody knows, everybody's Nowadays, they are talking about the nanoscale, like Dr. Sundaram pointed out. Even an engineer or maybe a technologist or maybe a doctors, whoever want to do some kind of fundamental research on their particular field, they are focusing on what's going on in a nanoscale levels. So as a material scientist and with a basic knowledge of chemistry, so we try to develop materials for a different applications. So these nanomaterials, everyone's have a well knowledge on this because of the high surface to volume ratio, as well as the novel electro and optical properties. So these material attracted much attention in recent days. So these material includes maybe a semiconductors or maybe a conducting polymers or maybe even a low cost carbon based material, etc. can be used for different applications. So this is a general classifications. This may be helpful to those who are not familiar with this kind of material research. So I want to just give you an overview of what are all the nanomaterial which can be available and which can be used for multiple applications. So this is a general way of classification of nanomaterials. The one is organic based and another one is inorganic based. In organic, there are different kind of material comes like a fluorines, dendrimers, liposome, as well as carbon-based nanotubes. That is a multi-wall as well as single-wall carbon nanotubes. In addition, the advanced materials like a graphene also existing for numerous applications. So whereas in the case of inorganic materials, in general, the metal nanorods, the metal oxide, or maybe a metal phosphide, carbides, etc., can be used for various sensing of bio and environmental molecules. So this is the classification of nanoparticle further based on the nature or maybe a surface type or how it may be available, either the uniform or maybe agglomerated one, and different type of compositions like a single as well as a composite material. And also it can be classified a physical and chemical properties like which one is a semiconductors or maybe a carbon based and polymeric material, etc. So this is purely based on a property based classification of nanomaterials. So in most of the inorganic nanomaterial, either based on metal oxide or maybe a pure metal based materials. So this is a dimensionality based classification of nanomaterial starting with 0 dimensional. For example, those material like a quantum dots, fluorines and gold nanoparticle comes under the 0 dimensionality. Most of these material either in a spherical in the shapes with a high active surface area. In the case of 1D material, it consists like a nanotubes, nanorods, or maybe a other like a nanowire, etc. So for 2D materials, either it may be a thin films or maybe a layered structure material comes under this 2D category. So these material like a graphene based and layered double hydroxides and layered materials attracted much interested for various sensing applications. So these are all the some of the example of 3D materials like a polycrystalline material and dendrimers. So this is the reason why the nanomaterial shows excellent activity for various applications. For example, this is the way how we can get the more active sites. For example, if you take a 5 cubic centimeter, that is about 1.7 centimeter per side of material. So if we divide it into 24 times, it can produce 1 nanometer cubes. If you spread the entire small cubes, it need at least the area of football ground size. So this is a bulk material. When we start to slice this material into a smaller scale, you can see the available surface area of each cubes will increases enormously. So this is the main reason of the higher activity of the nanomaterial based materials for various application, in particular for sensing of biologically relevant as well as environmental molecules. So this is the example of how our human skin may exist under a very focused scale. Like this is a 10 centimeter scale, that is as such what we are seeing. If you keep on reducing to like a 1 nanometer scale, we can easily see the either atoms or maybe DNA also. I just want to give some important materials, each class of material which is being used for various sensing applications. This is the example for carbon based materials like fluorines. This is a 0-dimensional one, and carbon nanotubes is a 1-dimensional materials. This is a graphene. So interestingly, all these carbon based material like a fluorine, carbon nanotubes and graphene have ended up with the Nobel Prize for their findings and its enormous applications. So in our lab, normally either we have to produce this type of nanomaterials by various techniques, and we can be able to use this material for sensing application, or some cases like some high pure materials like a 99.999 purity, either we can purchase from the chemical company and we try to like a functionalize with various functional group for different applications. So this is another class of materials called semiconductor quantum dots. It is nothing but a small colloidal particles with maybe nanometer less than 10, which is called quantum dots. So these materials shows the excellent application for various fields like a bioluminescent or maybe a photochemical application, fluorescent based sensing, as well as chemiluminescent based sensing applications. So this is because of the tunable size and very good optical properties of the materials. So in general, the brightness of these quantum dots is enhanced by 20 times, and the stability against the photobleaching is improved by 100 times when we reduce the size of the quantum dots into lower levels. So normally these type of quantum dot material shows a broad absorption and narrow emission spectrum, so which is a highly essential point to enhance the sensitivity of colorimetric based detection of many bio and environmental molecules. So we can also easily able to modify its surface for our application. That is, depending on the application, we can easily tune its size, surface for the particular applications. So the application of each class of material, maybe I will explain in the next coming slides. In this slide, I just want to give the overview what are all the attractive material which is being used for various sensing applications. So the next category of materials called gold nanoparticles. So this is the history of the invention of gold nanoparticles. So actually this material, if you see, it was invented 1857 by Faraday by a simple gold hydrolysis reactions. But after a continuous improvement by different scientists, now we have a very fine and very small structure of gold nanoparticle with a different dimension like a nano sphere, nano rod, or maybe a nanowire, etc. So these are all the some of the different types of gold nanoparticle which is we are using for multiple applications like a nanorods, branched like a chain like structure, nanostars, nanoclusters, nanocubes, and nanoshells. Even you can see in the gold cluster based material, it has a very good electrocatalytic activity for uh, uh, various reactions, in particularly for energy conversion reactions. If you tune its cluster number, it can show a different activity for particular reactions. So this is another group of materials, so they're called magnetic nanoparticle. So these material also shows exceptional properties for various sensing as well as catalysis applications. In this group of magnetic material, mainly either maybe a iron based material or maybe a cobalt or nickel act as a major group of material for the sensing as well as catalysis applications. So these are all the some of the application of that is magnetic nanoparticles. It includes like a biosensor to maybe a cellular detection or maybe a drug delivery, etc. So the another group of materials called two-dimensional materials. Nowadays, these material shows much attractive the other material because of the various properties like a high surface area, the conductivity as well as electron mobility, etc. So if you see the different 2D materials, like we are working on boron nitrides or maybe a metal disulfogenides as well as a metal organic framework and graphene based material for sensing and catalysis applications. So this I want to give a more idea about each materials. This is called graphene. It is nothing but a single atom thick sheet of graphite with hexagonally packed carbon structure. So here each the atom is covalently bonded through the sigma bonds. So this right top category of material called boron nitrides. Here boron and nitrogen atoms are hexagonally arranged by the covalent bonds. So this is a general representation of metal, that is a transition metal disulfogenides or maybe the exact name is a molybdenum disulfide. So these materials shows excellent properties like it's a solid lubricant for very long time. It acts a very good catalyst for petroleum refining and other like a heterogeneous process. But in addition to these very old traditional application, nowadays there is a huge invention on these transition metal disulfogenide materials. So we are also working for development of different structural and activity varied semiconductor transition metal disulfogenides like tungsten and molybdenum disulfide for various sensing applications. So these are all the structure of polymeric material called graphitic carbon nitrides. So which consists of carbon nitrogen and some impurity of hydrogen, which is connected in the network of the tris trizine based patterns. So these material not only showing a very good activity for a small application like a sensing, but in the point of like a engineering aspects, so these are all the potential candidate for various like a water filtration or maybe a lubricant application, and even the mechanical, if you want to improve the mechanical property, either we can go for with the graphene based or maybe a metal disulfogenide based material in the sense of engineering aspects. So I just want to give a few information about these particularly 2D materials. So in generally these 2D materials have a sheet-like structure with single or maybe a few atom thick. Most probably it may be a 5 nanometer thickness. So because of this high electronic as well as conductive property, these materials, particularly the 2D material based on metal disulfogenates, it is a very good for device fabrication applications. And also, these material possess a very good flexibility and optical transparency. Hence, it can be used for optical based sensing devices. So even though this material shows exceptional activity for various like a sensing as well as other applications, but there is some like a hurdles like a synthesis of methods for producing this 2D material with controlled thickness. That is, if you want to produce a 1 nanometer thickness of like a 100 gram or maybe a 10 gram of this material, it's really challenging task even in and today also. That is the point I want to convey is the development of size and shape controlled 2D material is a highly important for various applications. So this is some of the synthesis process which has been adopted for preparing these 2D materials. I just want to give you an overview. What are all the methods we can go for synthesizing these material? This is the well-known methods called a mechanical exfoliation or maybe a Scotch tape method. So this is the way how the graphene material has been produced from the bulk graphite sheet. So here is nothing but the bulk graphite sheet, graphite or maybe a bulk material of 2D material can be put on this tape, and if we apply some a mechanical force, we can end up with a very small, maybe a layer with a 1 to 2 nanometer thickness size of this material by applying a simple mechanical force. So the another method can also be possible to prepare these 2D materials like a liquid explosions by mechanical force as well as by ion intercalations. So in this mechanical force through liquid exfoliations, the bulk material can be treated in presence of some liquids, in particularly maybe a solvent, which is be suitable to exploit the material. And if you apply some force like a maybe a like kind of ultrasonication, we can end up with this layered materials. In the case of exfoliation, liquid exfoliation by ion intercalations, which is nothing but the intercalation of ions like sodium, lithium, potassium, etc., between the interlayer of the bulk crystal, followed by the applying some mechanical forces. So we can get a very high quality powders. So, but the disadvantages of the liquid exfoliation is this experiment is performed for a long duration. That is a minimum we need at least 1 or 2 hours. And also sometimes it expect a high temperature to get a very pure and high quality powders. So these are all the some of the disadvantages. So this is a schematic example of the exfoliation of graphite in through the solvent as well as by applying a surfactant followed by sonications. So we can end up with the single layer graphene from the graphite powders. So this is the example of lithium intercalations as well as followed by a exfoliation by applying a mechanical force. This is a bulk materials of like a graphite, and this is a bulk material of vanadium oxide. So you can see while we are undergoing the lithium intercalations, or maybe it can called as lithiation process. So the lithium ion may intercalated between the layer of this bulk material, followed by further treatment, we can end up with the single layer materials. So this is the FESEM images of the bulk to a nano sheet formation, and this is the high resolution transmission electron microscope of the sheet prepared through these methods. You can see here by applying different forces like incorporation of lithium as well as the further sonication, we can get it a very thin layer of these materials. So we can also synthesize these nanomaterial through maybe a ion exchange approach, like the previous we discussed here. Once we insert a small ion, like ions like a lithium or maybe a sodium or potassium, after that we can also able to insert another bulkier ions to the previous one, and followed by exfoliation we can get a very nice single layer structure of the materials. So this is another example which is nothing but the oxidation and reduction methods. Here a strong oxidizing or maybe a reducing agent can be like a potassium permanganate or maybe a hydrogen sulfide, uh, H2SO4 can be used for oxidize the fines um, the topmost layer of the particular materials to give a single layer structures. So during this oxidation and reduction process, what will happen that carboxyl, hydroxyl and epoxy groups on the surface can expand the inner layers. So these leading to reduction in the van der Waals attraction forces to the continuous layer of the graphite. So at the end of the continuous process, we can end up with the single layers of the particular materials. So this is another method called selective etching, which is nothing but by utilization of a strong chemicals like a HF to etch the single layer of the material from the bulk one. But the main disadvantage of this material is due to the strong corrosive nature of the materials, the handling of this particular system itself a little bit tough than the previous ones. So in addition to these traditional like exfoliation methods, nowadays there is a advanced methodology called nanolithography can also be utilized for developing some kind of 2D materials. So this is the one example I just want to give uh, for if you want to prepare some kind of small cluster size of maybe a gold or maybe a whatever maybe the metals like a platinum monolayer or maybe a platinum dots or maybe a, so we can go for nanolithography patents. You can see this is a 500 nanometer scale. Almost most of the small dots comes less than 50 nanometer scale of gold nanoparticle. So the most interesting point of this particular nanolithography, you can see here from the top and to the bottom, if you want to make like a maybe a hundreds or maybe 1,000 number of nanoparticles on a single platform, for example in the sensor, if you want to make a golden nanoparticle with maybe a 100 nanometer size, 100 numbers, we can do with the help of nanolithography, and each nanoparticle can help to enhance the sensitivity as well as the selectivity of the sensors. So this is the most advantages of the nanolithography based material developments. So in addition, whatever we have discussed comes under like a top-down approach, that is a bulk to nano layer, that is a bulk material to single layer formation. In addition to this top-down approach, we can also go for this bottom-up approach. This is a traditional methods which is practiced in many laboratory, that is a material synthesis lab, which includes a chemical vapor deposition, maybe a photochemical synthesis, hydrothermal and solvothermal methods. I hope most of the members, those who are present in today's meeting, are familiar with this material preparation. I just want to give just a glimpse of this material synthesis. This is a synthesis of maybe a molybdenum disulfide, that is a 2D material through CVD, that is the chemical vapor deposition methods. And after making on this silica substrate with the molybdenum and sulfur sources, we can end up with a very fine and maybe a few layer MOS2. So this is the another example of making a tungsten disulfide based material through CVD methods. So in hydrothermal and solvothermal, these are all the very simple and scalable route of materials. For example, if you want to go for like a maybe a exfoliation or maybe the CVD methods, so it is a possibility of preparing maybe a very low quantity of materials. But in the case of hydrothermal and solvothermal method, so we can even sometimes we can prepare like a bulk scale of material in maybe 100 gram, or maybe in some cases in solvothermal material, solvothermal methods, we can prepare like a kg level of nanomaterials for different applications. So in general, these hydrothermal and solvothermal are simple and scalable routes. So this reaction maybe either can be performed under like a autoclave, or maybe in a room temperature. So here maybe the the pressure as well as the solubility of the particular precursor can decide the material's quality as well as the size and its various physicochemical property. We can easily tune the morphology and size based on our recipe. That is, if you want to prepare some kind of nanorod or maybe a nanodot, whatever may be, we can just tune the recipe of the particular synthesis and we can prepare the material very easily. So in general, the 2D nanosheet prepared by this method always end up with the multi-layers rather than the mono layers. That is, if you want to go for a preparation of a layer material like a graphene or maybe moly sulfide with a low cost, we can go further. We can go first for this hydrothermal or maybe a solvothermal method to produce a huge quantity of material. After that, maybe we can either utilize a exfoliation method like a simple ultrasonic method, or maybe some other lithium intercalation, or maybe a sodium other intercalation, ion intercalation. We can end up with the single layer materials. So in hydrothermal method, it's a known one. Water used as a solvent, and solvothermal method use either non-aqueous solvent like a ethylene glycol or maybe a DMF and other solvents. So this is a simple. I just want to give the like a overview how the entire reaction will be carried out in like a hydrothermal conditions. This is the synthesis method of moly sulfide using sodium molybdate and L-cysteine. After hydrothermal treatment, maybe 24 hours or maybe 48 hours. So this is the one disadvantages of these hydrothermal and solvothermal method. It needs a long duration for making these materials. At the end, but we can end up with a like little high quantity of these materials. So these are all the some of the materials we have prepared in our laboratory. This is a moly sulfide and this is a copper sulfide. Both are it comes under metal disulcogenide, metal sulcogenide materials. So after preparation of this material, normally we used to test its physicochemical property before going for the sensing applications. So in addition to other methods like a photochemical methods, by utilizing light as well as a microwave irradiation method can also be used for sensing, synthesizing of these materials. In photochemical method, it's a well-known concept. The light can be used for irradiations. So during this light irradiation, what will happen? The superoxide and ethoxy radicals will be formed in the solutions. These radicals act as a very strong reducing agents to reduce the particular metal into its nanoparticles. So this is the case for gold nanoparticle synthesis using gold chloride solutions. But it depending on the metal precursor, we can end up with the very good quality of these materials. So these are all the some of the simplest synthesis method of materials, which can be not only be used for sensing application, it can used for various engineering application also. So these are all the some of the important characteristics which is being used to analyze. Not only the synthesis is highly important, but before going for particular applications, we need to categorize, or maybe we need to analyze the material very properly. If the material is not formed properly, we cannot expect the activity. The activity, it may be a sensor, or maybe a catalysis, or maybe it may be any engineering applications. So we need to carefully analyze the material property. So I just want to give the importance of Raman spectra and electron microscopy analysis for characterizing the 2D materials, particularly like a graphene, transition metal disulfogenides, and boron nitride and graphitic carbon nitride, because these are all the some of the attractive material which is normally most of the research now focusing for various applications. So this is the first one using Raman spectroscopy. Raman is the powerful characterization methods. It's a non-destructive method to develop, to characterize the 2D materials. So these are all the important parameters, like the shape of the Raman lines, the position of the Raman line, how it's differ from the bulk, as well as the full width half maxima of the particular the peak, and the intensity of the particular peak also highly useful to predict the structure of the particular 2D materials. So this is a some example in under the high resolution transmission electron microscope, as well as the Raman spectra, how the 2D material will behave. So this is the example you can see in the left side. This is a high resolution transmission electron microscope. If suppose if you are focusing to make a like a electronic instrument which can be used for sensing of gases, that is it may be a gas sensor based on nanomaterials, maybe a moly sulfide or maybe a tungsten disulfide. In most of the cases, either single layer or maybe a few layer, that is a 2 layer or 3 layer, shows a except very good activity. So once we complete the synthesis, if you are measure the if you analyze the HR analysis, we can easily end up with the layer numbers. You can see here this is a 3 layers and 2 layers structure. Not only the 3 and 2 layer, which can also exist a multi layers like a 7 layer, 8 layers in the particular synthesized materials. So based on this characterization, either we need to go for further modification of this material or maybe a recipe, we can end up with a few layer structures. So this is a Raman spectra of the same material, like from a single layer to 5 layers. You can see how these Raman band varying, and if the layer number is increased, the band position keep on like shifting from both left side as well as the right side. So the distance between these two Raman intensity or maybe a Raman peak give you an idea about this layer number of the 2D materials. So just want to give maybe many of the faculty, those who are interested to analyze the 2D materials, this is a Raman is a most powerful and easily available characterization techniques we can easily analyze the layer number through the Raman spectrum methods. So up to this, I just given the idea about the materials, and I just want to move to the material to the sensing aspects. If you have any doubt or maybe clarifications, you can please ask. Is it audible? Hello?
Hello. Sir, audible? Hello.
If you have any queries, you can ask, or else I can just move on to the real topic of sensing applications.
Sir, any? Sir, no, sir, no queries. Sir. We continue
Okay.
after 5 to 10 minutes later, sir. No problem.
Okay. Okay. No issue. So I will wait. Maybe after 5 minutes, I will start the remaining portion of the electrochemical sensing of healthcare and environmental monitoring using the synthesized materials. Thank you.
வச்சிருக்கேன். ரிமைனிங் நான் க்ளோஸ் பண்ணிடுறேன். மற்றெல்லாம் க்ளோஸ் பண்ணிடுறேன்.
Hello.
So we continue the session, sir.
Yes, sir. Sure, sir.
Okay, sir.
Yeah. So, thank you. Just want to move on to the real application of this material called a sensor. So, sensor, you may aware, maybe you can see some of the small type of sensor. For example, the glucometer, which is most of the houses nowadays we have a glucometer to monitor the glucose level of our maybe elderly people present in our houses. So it's a device. It can provide a continuous information about the environments. So in the environment means if you want to monitor our health, it can give a continuous information about the health, that is a biomolecules. Also, it can also give the environmental molecules which is present in the environments, like what are all the molecule which is present in the air, water, and as well as the soil, etc. So in chemical sensor, it can provide a type of response which is directly related to the quantity of a particular chemical species. That is, if you want to measure like a NO2 in the atmosphere, so the signal or maybe in the number which is shown on the particular sensor device is only for the particular materials, that is a NO2 concentrations. So in chemical sensor, there is a chemically selective layers. It may be a matrix, that is nanomaterials, or maybe some other form of chemically selective layer which is placed on this particular sensing. It can react with the molecules and give the like a signals. So it also consists of a transducer, and it can transform the response into a detectable signals. So for example, the transducer which is present in the metal oxide based sensor, once the gases will enter and it will react with the metal. So whatever the quantity or maybe whatever the concentration, it can be transduced by the transducer, and the corresponding signal we are seeing on the display board. Sorry. Sorry for the inconvenience. 1 minute. Sorry. So normally the sensor can be classified depending on these applications. Like if you want to measure some mechanical property or maybe optical, thermal, electrical, etc. So we can develop the sensor. So this is a classification of nanosensor either on the basis of receptor molecules or maybe the structure of the basis of structure or maybe the basis of applications. On the basis of receptor molecules, like in during the COVID period, this corona period, the rapid testing kit has been developed based on this uh, sensor, which is working on the principle called affinity based sensor, that is immune antigen antibody based sensor. And also there is a other category of sensor called catalytic sensor. It's nothing but a glucometers. So it can, the glucose can be catalyzed by the enzyme which is present on the particular matrix. So on the basis of structure, either it can be classified like optical nanosensor to measure amplitude, energy, maybe a polarizations, delay time and decay phase, etc. And also there is a availability of electrochemical sensor to measure a electrochemical and mass transduction mechanisms. So it can be classified differently based on this application, like a chemical nanosensor and electrometer, a biosensor, etc. So electrochemical sensor, which is comes under three different category called potentiometric sensor, amperometric sensor and conductometric sensor. These are the three different principles how the electrochemical sensor is working. In potentiometric sensor, what will happen in a local equilibrium is established at the sensor interface, and the information about the composition of the sample is obtained from the potential difference between the two electrodes. For example, nowadays we are using many ion selective electrodes and pH electrodes in the laboratory to verify the pH of the particular solutions, so which is nothing but the potentiometric principle, which is nothing the which is working on this potentiometric principles. So for the amperometric sensor, it's exploit the use of potential applied between the reference and working electrodes. We are measuring the resultant current. So nowadays the glucose sensor what we are using, it may work under the principle of amperometric principles. So like a gas sensor can be working on the principle of a conductance variation between the analytes. So this is the electrochemical biosensor. Biosensor is nothing but an analytical device that incorporates a biologically active elements with the physical transducer to generate a measurable signal which is equal to the concentration of the biochemical species. So this is a simple representation of the sensor, how it looks and what is going on the matrices. For example, this one, the green color is analyte molecules. So this red is a biological recognition elements or maybe a enzyme. I can explain with the example of the glucometer, glucose sensor. If you consider this is a glucose molecule, so this is the enzyme, that is a glucose oxidase enzyme, which is already preloaded on the electrode matrix, which is given by the maybe the healthcare provider as a strip along with the instruments. So these strip contain the particular enzyme preloaded, can be stored in our refrigerator. So whenever we need to analyze the glucose level, we just prick the finger and take a small drop of blood and it can be placed. So the glucose which is present on the blood, it will interact with the enzyme which is already preloaded on the strip, that is called electrodes, and it can undergo electrochemical reaction to produce the hydrogen peroxide. This is the product one, which is nothing but the hydrogen peroxide. So during this electrochemical conversion from the glucose to hydrogen peroxide, there is liberation of electrons, that is a 2 electron, which was further transduced with the help of these electrodes to the meter. So based on the concentration, we will end up with the value, this much of glucose present in the bloods. So this is the simplest way of explaining the principle of biosensor, how it is working. So what are all the biosensor elements? That is the important elements in the biosensor. So it consists of three different groups. The sample category. The sample category is nothing but what are all the sample we need to analyze. For example, if you want to analyze some air, water, soil, or maybe a food sample, or maybe a human saliva, or maybe a cell culture, it comes under the category of the sample category. So these, like a transducer, is nothing but the signal which is produced from this sample by applying potential or maybe applying current, can be transduced with the help of these materials. Sometimes it can maybe a biomolecules like a nucleic acid, or maybe a cell, or maybe antibodies, or maybe an enzyme. And most of the recent days, like a nanowire array, or maybe a nanoparticles, or maybe a bulk electrode, can also act as a transducer to enhance the signal of this molecule to the device. So those maybe if there are students like a master students, or maybe a bachelor students, or maybe a research scholars, those who are in the line, I just want to highlight the possibility of various group of peoples. For example, those people having the background of chemical, biochemical, or maybe a nanoscience, or maybe a biomedical engineering, have a very good chance, maybe opportunity to develop some kind of sample as well as a transducer for the particular sensing elements. In addition, those who are interested in the electronic background have a very good opportunity for making a new type of electronic devices which can sense maybe a nanomolar or maybe a picomolar level of particular molecule. That is the point I want to convey. So those who are interested in electronic instrumentation aspects, they can have the ability to enhance the signal from like a picoampere current to a detectable range. There is a great opportunity to make a new devices for sensing applications. So this is a general representation of the application of various sensors. Like it can be used for healthcare, maybe environmental monitoring, food analysis, and security. So I try to cover at least few of the application bar various like a healthcare, like a food and environmental and security, etc. One or two important application with some example of nanomaterial which is being used to enhance the signal. I will present in the coming slides. You can ask what is the importance of nanomaterial and how it can enhance the sensitivity, selectivity of the particular materials. So this is the one slide. I try to give an idea why the nanomaterial based sensor shows excellent activity compared to the other materials. For example, this is a bulk electrode, the left to top on A. So this electrode, once the molecule will reach, it can be placed either 1, 2, 3, or most probably a 5 different places. Whereas if you see the figure B, this is a nano sensor, maybe a what we discussed like a nanolithography based. If you consider this is a gold nanoparticle, if we placed on this top of the electrode like this pattern, each analyte molecule maybe interact in the different way. You can see these are all the analyte molecule. 5 analyte molecule, it can reach the small nanoparticles with different area or maybe a different orientations, and it will give a enhanced sensitivity, enhanced signal, or maybe amplified signal compared to this bulk electrodes. So if that's what the nanomaterial based sensing application is attracted much attention due to this highest maybe a very good signal amplifications. So this is a continuous or maybe a array electrodes which consist, each electrode consists of numerous nanoparticle. It can interact with the, you can see the here each nanomaterials once the molecule, the biomolecule or maybe environmental molecule once reach its surface, it can readily undergo the redox reaction and it will enhance the sensitivity of the particular molecules. So this is the just I want to give an overview of the importance of carbon-based nanomaterials. We already discussed like a carbon nanotubes, carbon nanodots, or maybe a graphene-based material for various sensing and applications. The highlight of this work, if you see here, 1985 to maybe this is a old one, but now 2022. So once whatever the material they have invented due to its extraordinary property, there are numerous applications have been immediately identified by various researcher and reported for various application. So among these, this is the one of the best application. It's nothing but the like a bioimaging. If you want to monitor some disease, so we can use either any type of nanomaterials or maybe a quantum dot based material, and it can give a very good imaging of the particular disease. So this is the one example like in vivo fluorescent imaging of to monitor some like C. elegans with the help of these carbon dots. You can see after injecting this carbon dot with this mice with this optical images, we can clearly see where are the infected cells, so how it will react with this particular medicine, etc. So this is another example to monitoring the in vivo nitric oxide sensor. That is, a nitric oxide is a important biomarker to give a various, that is a possible diseases. So you can see here this single walled carbon nanotube functionalized with different molecule, and it can be injected on this mice, and it can give the liberation of NO2 from these mice. Depending on this concentration, we can easily say the level of NO2 on these particular systems. So in addition to this imaging, there are numerous molecules like if you want to monitor whatever may be the molecule, they like a neurotransmitter called dopamines. If you monitor our neurological function, we can easily develop some kind of nanosensor with carbon nanotube based active substrate. We can end up with, you can see the 1 nanomolar concentration can also possible to sense with this type of sensor. In addition to this neurotransmitter, many like a DNA, RNA, and vitamins, etc., can be easily sensed or maybe easily determined using the carbon-based nanomaterials. So this is some of the example of graphene based. Due to the lack of time, I just only give the overview. If you want, maybe I will share the link in the during the next slides, or maybe the particular reference paper. You just note it on and you just go through. It will give the exact information about how the nanoparticle play a role to enhance the sensitivity and how it work with a very wide linear range and other properties. So in continuation of these carbon nanotubes, like these graphene based material also can be used for detection of various biomolecules. It can end up with a very wide linear range. The linear range is nothing but in our body, everyone have the glucose or maybe whatever may be molecules like uric acid or maybe vitamins. There is some normal range. For example, in vitamin C in our normal body, it may exist with a few micromolar, like 20 micromolar. I am just giving an idea. Normal range of these particular vitamins may be either micromole 10 micromole to 120 micromole. It's a common, it's a normal level for all the human beings. Once the level it start to reduce or maybe it may increase, it will end up with a different kind of diseases. So this linear range is nothing but, so our developed sensor in the laboratory, it can work if the particular blood molecule may contain 0.5 micromole, it can show a signal, or it may have the same time 2000 micromole of the particular molecule, that's a glucose molecule, can also be able to sense with the help of this developed sensor. So this is called a linear range. That is the range from 0.5 to 2000 micromole. The developed sensor can show the signal of the particular molecule towards the particular molecule. That's a glucose molecule. So this is the some of the example quantum dot based biosensor, like a carbon material. The quantum dots, it's nothing but quantum dots, a small molecule that is a less than 10 nanometer sized nanoparticles called quantum dots. It can source a exceptional fluorescence property and ECL, that is the electrochemiluminescence activity, and for sensing of various biomolecules like HIV virus, like a DNA, and other biomolecules like a cancer cell, like a dopamine and others. So this is an example of AU nanoparticle, that is gold nanoparticle based sensor for sensing of metal ions in the particular system. Either this may be a environmental or maybe a biological based sensor. So this can, once the metal will interact with this gold, it can easily undergo a complexations and the color will immediately change to from maybe like a pink to blue color. The corresponding fluorescent intensity also start to quench. Based on the quenching we can easily tell that particular concentration of the metal ions. So this is another example of detection of mercury. Here also you can see once the mercury will interact with this gold nanoparticle, due to the complexations, the color of this particular nanoparticle will immediately change to the blue color. Based on the color and the fluorescence value, we can easily say that this is the particular level of mercury present in these systems. So this is you can see the peculiar behavior of quantum dots. So you can see this is the example of cadmium selenide zinc sulfide based quantum dots with different size. You can see in the top the diameter of this particular molecule will vary only 2.7 to 4.8. That is approximately variation in this size is only 2 nanometers. But each variations like a 2.7 to 2.9, you can see the color changes and the corresponding photoluminescent value will vary from 510 nanometer to 530 nanometers. So this is the reason why this quantum dot based material shows a different color based on its size. You can see this is the 4.8, the red one, and this is the 2.7 in this blue color. This is a reason because of the existence of conduction and valency bond gaps. So in this case of bulkier quantum dots, these conduction band and valency band is very closely placed, whereas in the case of smaller quantum dots, these two bands differ somewhat higher energy, so that it behave a different way of emission spectrum during the applications. So this is a example of a different application of quantum dot based sensing. Like this quantum dot based material can be used for a biomedical sensing. This is one example, which is nothing but the immuno sensor. Immunosensor is nothing but it's an antigen antibody based sensor. It can also utilized for various simple sensing of molecules. This is the one of the example, like capturing MCF7 cells. You can see based on these concentrations, the intensity of the fluorescence will differ significantly. So this is another example for quantum carbon dot based, that is a quantum dot, in particularly for carbon dot material for sensing of this glucose. So this is a before and this is a after reactions. This is a carbon dots functionalized with various molecules. Once the glucose will interact and it will undergo a reaction with the glucose oxidase and it will produce hydrogen peroxide, the corresponding color of the original carbon dots will change from this blue color to this color, that almost like a light yellowish in color. You can see the values of this fluorescence. It will vary from 446 nanometer to maybe around 550 nanometers. So these variation will give an idea about the sensitivity of the particular sensors. So this is another example, detection of monoamine neurotransmitters using carbon dots. Here also you can see by changing the concentration, so these carbon dots will interact with this molecule and change its color. Based on the color as well as the changes in this intensity value, we can easily say the level of the particular molecule in these systems. So this is a overview of 2D materials, in particularly 2D transition metal disalcogenide based material. So these material in general have multiple applications like electronic device fabrication, biosensor, piezoelectric device, photonic device, and gas sensor. So this is because of its exceptional layered property as well as the existence of highly active surface sites. So this is a application of MOS2 based on different its like a dimensionality. If suppose if you want to develop some fluorescent based sensor using MOS2, we need to go for either MOS2 quantum dots. So these quantum dots, because of this quantum size effect, it can give a sensitivity for various molecules. So in addition to this fluorescence, this material also can have the capability of electrochemiluminescence in the maybe a nano rod or maybe nano wire form, or maybe it can use for electrochemical application in a 2D format, and also can be utilized for colorimetric application by 3D structure. That is the points I want to convey is the same simple single molecules. If you alter its dimensionality, we can end up with the different applications starting with fluorescence, electrochemiluminescence, electrochemical, and colorimetrics. So this is the point I just want to convey. So this is a one example. Just want to give how this MOS2 will behaves. So this is the electrodes. Here I just give a classical a bulk electrode which is we are using in the laboratory called glassy carbon electrodes. Once we synthesize this material MOS2 using various methods what we have discussed in the early, after characterizing we used to go for preparation of the ink and draft casted on the surface of the electrode. This developed electrode can be placed on the electrochemical cell which contains the like analyte molecule, either maybe a glucose or whatever may be. This is the case for sensing of glucose. So once we tip the like a electrode on the glucose sensor, by applying the potential, this glucose will undergo reactions and it produces a hydrogen peroxide. So this hydrogen peroxide, so we are monitoring on the surface of these electrodes. So in addition to the traditional sensing applications, there are a huge application for these 2D material in recent days for wearable sensor application. I believe that now most of the people, those who are going for in the morning walking or jogging, either they have some kind of wristband or maybe some kind of small devices on their arms or maybe in the head. So which consist of numerous small type of sensor, in particularly like iPhones, like Apple phones and Apple Watch, and somewhat high watches also nowadays coming with these kind of wearable sensor. So that sensor which consists of small like a nanoparticle which is already placed on this sensor matrix. Once the biomolecules from maybe a sweat or maybe a saliva or maybe through the teeth, it reaches on this sensor matrix, it will react on this nanoparticles and it produce the signal. This signal is monitored through the display of the particular system, that is watches or maybe a small devices, etc. So this is a somewhat attractive development of wearable sensor for wearable and flexible sensor which utilize the 2D materials for various applications. So just want to conclude the healthcare based sensor. So this is a future scenario of healthcare monitoring in olden days or maybe even today also. So if you want to monitor some health risk or maybe a health diseases, what we are doing, either we need to go for the hospital after taking our blood and after a thorough monitoring validation of the particular elements. Like if you want to monitor maybe a glucose level, you need to go for the laboratory, a hospital, they will take your blood and they will analyze the glucose level, and maybe they will tell the result maybe a hour or maybe a day. Because of this development of wearable or maybe a small type of portable sensor, so now there is a possibility, like we discussed in the earlier slide, in the wearable sensor. So the idea is to we can place a different sensor on the human body during the process, like walking or maybe whatever we are working in this laboratory during some different condition. For example, if we are under high stress or maybe a high pressured conditions, or maybe a high emotional depressed condition, some biomolecule may come up with maybe in the saliva, in maybe in the sweat or maybe other another molecules that can react with this wearable sensor. So all these data may be monitored through this our smartphone. So this smartphone may be connected with a fixed gateway, and it can be easily passed through the doctor through this internet IoT of things. So this healthcare provider or maybe a doctor, they can give a tips. So your level of sugar is going rapidly, you please take this medicine immediately, like that. So this scenario, it's already started, and various smart sensor development companies are working. So I'm happy to say that in our divisions like electronics and electrocatalysis, we are also working for development of various flexible and wearable portable sensor for monitoring of healthcare molecules, that is a biomolecules, which includes monitoring of glucose, monitoring of kidney markers, that is a kidney disease marker, and many cancer cells, etc. So with this, I just move on to the electrochemical sensor for environmental monitoring. So I don't want to give a reason for why we need to go for monitor the environment, because we know everybody so what's going on. So this is a somewhat important parameters. What are all the important things we need to monitor on the environments, which includes heavy metals, pesticides, antibiotics, pathogens, phenolic compounds, and gases. These are all the most materials we need to monitor in the environment to predict our nation's very healthy and safety. So what will happen? So if we are not properly monitoring or maybe properly maintain the environment, these are all the adverse effects. You can see whatever the disease, it can be come under the severe environmental pollution conditions. During this last Deepavali, after the Deepavali, I hope that most of them heard that most of the metro cities, the level of contaminant rapidly increases due to this pollution of various chemicals and the crackers. So this is a need of environment to access the effectiveness of environment, as well as the level of contaminants like metals, organics, and other things. We can also have an idea about what may be or what are all the possible diseases which may occur because of these pollutants, and how we can prevent the environment and through the monitoring of the contaminants. So in addition, it can helpful to monitor the health of soil, water, as well as the environments. So these are all the traditional technology, traditional methodology, right? Even today, how we are analyzing all these environmental sample, either we need to go for a high-end like atomic spectroscopy or maybe a mass spectra or maybe a chromatographic method. The advantages of this method, we cannot say that the portable sensor is the superior. So these are all traditional method always a superior compared to this rapid like a handheld device. But due to these disadvantages like a expensive complex procedure for preparing the sample and the need of the expertise people to operate this instrument and taking a very long time for a simple one analysis. So we need to identify some rapid like a portable sensor to analyze the environmental molecules. So this picture gives an overview of environmental sensing, which includes soil sensor, water, air quality monitorings. So these are all the some of the heavy metals which is highly in toxic nature, like a copper, mercury, cadmium, chromium, arsenic, etc. We need to monitor its level on the drinking water as well as another other household water, etc. So this is because these heavy metals are very hard to degrade. That is, it needs more time to undergo a biodegrade, maybe a years or maybe a more than that. So what will happen? It can be easily accumulated in vivo by maybe a biomagnification effect of the food chains. That is, these heavy metal present on this soil or maybe water, it can easily penetrate through the crop to the food, and finally the human will have the contamination of these heavy metals. So these are all the some of the parameters of different countries. They are following the level of different heavy metals, the level of heavy metals. Once we exit from its levels, it need to be monitored very carefully and using various technology like a sensor or maybe other traditional methods. So this is like a slides which give a overview of the impact of lead ions in particularly. If you see, you can ask where is the source of these ions? Lead. For the sources which include lead pipes, or maybe batteries, traditional medicines, or maybe a paint, gasoline, and various industrial activity. These are because of these sources, these ions, the enormous of ions is producing every day. Because of the lack of recovery of these ions, it will easily penetrate through water to the through various like a wastewater from the industry, particular industry, and finally it can reach the drinking water or maybe through soil, and it can have multiple health like a disorders. You can see how much there is a huge different type of diseases will occur based on its like a entry. For example, if we take the reach the lead in the respiratory, through this way like a airways, it can maybe increase the total and differential white blood cell count and increase the inflammations. For example, if reach through digestive systems, it can have different diseases like a increase in the protein and globulin, etc. So that is based on this storage, absorptions, and source, etc. It can give various tremendous different type of diseases. So this is the maximum limit of lead ions in drinking water. It may be 72 nanomolar by US environmentals, whereas 48.26 nanomolar by International Agency for Research and Cancer. You can see between these two different agencies, there is some flexibility for this maximum allowable level of this particular lead ions. But the most interesting thing is whatever maybe it may be a 72 or maybe a 48, it is in the nanomolar range. So if suppose there is some lead ions, we can easily sense using the electrochemical methods. This is a one example based on the nanoparticle based sensing of the lead ion using Optimus. You can see this is a screen printed electrode loaded with this nanoparticle. So in the absence and the presence of this lead ion, you can see how this current value drastically vary. Based on this current and this particular potential, this particular developed sensor can end up with this 0.6 parts per billion level of lead in this particular systems. The similar way, the another methods which is reported using like a iron based nanomaterial can also utilized for sensing with very low detection limits. So this is a copper based material developed by the homemade and tested for sensing of the copper ions. So it will end up with 4.4 parts per billion concentration of lead on the particular solutions. So this is another example based on multi-wall carbon nanotubes coated glassy carbon electrode. You can see from 1 nanomolar to 1 micromolar level of these lead ions, how the current value is increased drastically. Based on this current, the developed sensor can sense up to 0.5 nanomolar level of lead on the particular systems. So this is the another example of cadmium sensor. So like a lead, the cadmium also shows a very serious health impact. So this is some of the source how the cadmium will reach, like a electroplating industry, nickel cadmium batteries, alloy and pigments, and other like a pesticides. So it can also easily reach via the water molecules, and it can also give a various diseases. So this is among the one like a Itai disease, which was invented, identified in 1912 in the city of Toyama, Japan. So the actually in this particular region of this particular Toyama city of Japan, most of the peoples are on the year like a 1912 or maybe on the same around 1910. So most of the people have the health impact with the curved like a structure of the backbone, as well as there is a huge curvy legs. So initially it is give a very tough to identify what may be the reason, but after a series of like a research, this company they produce a huge amount of cadmium. The wastewater which is not properly treated, the cadmium was exposed to this water body. This water body which is further used to the cultivate different type of crop on this particular zone of this Japan. So because of this over accumulation of the cadmium, it may reach through this food stuff to reach the human body. Because of this cadmium, it end up with this curvy nature of the backbone as well as the legs. So after this invention, you can see it take almost like a 1972 to 2002, almost like a 50 years to recover to or maybe remove all the cadmium in the particular lake or maybe particular water body. So the message I just want to convey, whatever maybe the heavy metals, we need to take more like a precautions before, if you utilize for maybe a drinking or maybe a agriculture applications, we need to take more precaution to analyze is there any particular heavy metals which may present on the particular water bodies. So this is a sensor which is developed based on nanomaterial, that is a reduced graphene oxide unloaded with tin oxide, so which is used for simultaneous detection of different heavy metals like a cadmium, lead, copper and mercury. You can see the bare GC and graphene modified electrode also shows a excellent sensitivity towards these particular molecules, and the developed sensor have a very good level of that is a low detection level of like a 0.10, 0.18 and 0.22 nanomolar level of the particular metal on the systems. So this is another example based on graphene oxide loaded gold nanoparticle for sensing of the heavy metals. So this is for cadmiums. So these developed sensor also shows a very good lowest detection limit with wider linear range. So in addition to this lead and copper, this arsenic also a highly pollutant or maybe a toxic metals. So this is the status of our various like a state of India, how this value you can see this is affected population, this is a state affected, you can see almost 70.1 in Uttar Pradesh and 63.6 like that. If you see the overall, almost like a 18.8% of India is total population drinking a arsenic contaminated water every day. This is a statistical reported collected from the health and maybe a pollution control board. So the message I want to convey is the most of the states, the drinking water level, the contaminant arsenic is a little bit higher. So we need to take more precaution to analyze the level of water. So instead of going for the traditional methods, these are all the simplest electrochemical based sensor which utilize the nanoparticle for sensing of the molecule. I'm just given the overview. So this is among the one like a, rubidium piperidine loaded graphene oxide. This is a graphene oxide based 2D material loaded with this chemical which is used for sense the molecule. You can see based on this concentration the current value is drastically increasing. So these developed sensors shows very good lowest detection limit. So this is another example which is based on the enzyme based sensor for cadmium, lead and copper detections. So this is the another example based on like a activation. This is the graphene based material on the glassy carbon electrodes and the various other material which is used for detection of the particular analyte molecules. So in addition, the fluoride also a dominant like a heavy metal contaminant. So this is the impact of fluorides. I hope many of you are aware that. So the fluorosis is a disease which occurs from ingesting elevated level of fluorides. You can see the legs as well as the hands of these particular peoples because of the fluoride contaminations over level that is a exceed level of fluorides. You can see the teeth conditions almost in some particular places this fluoride level will be much higher, because even sometimes the rock or maybe the soil also have the problem of fluoride content, the excess fluoride contents. So this gives an overview of various states of our India have the fluoride impacts. So you can see almost many states have the fluoride impacts. So recent days, many advanced like a fluoride removal methods which is being adapted, but it will not reach the entire population. Like metro cities or maybe major towns, the peoples have the ability to take a very good or maybe a refined water, but like a villages and other places, still date people have the problem of taking these contaminated waters. So this is the methodology which is being reported for sensing out the particular fluorides based on this molecule like a bis indole methane, which is functionalized with the multi-wall carbon nanotubes. Before and after the fluorides, you can see the variation in the current. So based on the current value, we can easily conclude that the particular system contains this much of fluorides. So these developed sensor can detect up to 0.1 micromole level of fluoride on the particular systems. So this is the another example, which is nothing but the development of EDOT. This is a polymer which is called electroactive polymer, can be used to develop sensor. So after entering this fluoride molecule, its structure will change, and because of these structural changes, there is a changes in the current, and based on the current value varies, we can easily conclude the level of particular contaminants. So these developed sensor shows a value of 0.19 ppm fluoride on the particular systems. So in addition to fluorides, this is another class of dangerous chemicals, that is it's a polyaromatic hydrocarbons. So it can arises through our daily day activities like cooking vegetable oils, that is repeated cookings. If, for example, if you heat the oil from 170 to 220 degree in the presence of oxygen, because of this thermal oxidation of this wares, cooking wares, it can produce this polycyclic aromatic hydrocarbon, as well as sometimes in the cooking oil itself, the repeated use of cooking oil. That's why the healthcare provider or maybe the doctors will advise don't take repeated uh, cooked oil for cooking and taking the food for continuously, because of the existence or maybe a formation of this polyaromatic hydrocarbon, which is highly carcinogenic, which can easily interact with maybe a proteins or maybe DNA or maybe a lipid molecules, and it can final end up, because of this mutation of these different process, like if you enter to the protein, it will undergo enzyme deactivation and protein degeneration. After that, it will go for the cell and membrane injury. This will end up with the cancers. If suppose it will interact with the DNA or maybe RNA, this will undergo this process, and the final causes will be a cancer market. It will create a cancers. So we need to monitor this kind of polyaromatic hydrocarbons also. So the impact of consumption of rapidly or maybe a cooking oil in the incident. So this is the articles. If you want to go through further, you just note that this is from Critical Reviews in Food Science and Nutrition, 59/3/2019. So this review will give an entire overview of the impact of polyaromatic hydrocarbons and how it can be generated, and what may be the physical causes, and how it can detected using various methodology, etc. So among the various methodology, I just want to give the idea about the electrochemical sensor based on the nanomaterial can also have the ability to sense this kind of polycyclic aromatic hydrocarbon. So this is the different hydrocarbon which is tested using the synthesized nanomaterial. So that is a graphene based nanomaterial which is functionalized. So you can see different molecules like a 2-hydroxy naphthalene, 3-hydroxy naphthalene, etc. It can produce different signal and different potential value. Based on this concentration, we can easily say that the level of particular contaminant in the systems. So this is another example of resistant based sensor. So using a polyurethane layer of, that is a metal imprinted polymers for sensing of anthracene, pyrene, pyrrole, etc. So among these various molecules, these developed metal imprinted polymers for only for anthracene sensing. This is also called a polyaromatic hydrocarbons. So these molecules will exist for various applications. So these sensor can detect this molecule in presence of other like interfering molecules. So the point for electrochemical sensing aspects, the developed sensor have the ability of sensitivity, selectivity, and very low detection limit, durability, and repeated use. These are all the important parameters we have to develop for the particular sensor. In case if you want to develop some nanomaterial based sensor, so the sensor after development, it can obey all these parameters like a sensitivity towards the particular molecules. For example, this is the molecule of our interest, anthracene. Not only anthracene will be present on the particular system, like other molecule like a pyrene or maybe a pyrrolene or whatever may be, which is can exist during this cooking process, it may also available on the particular system. Even though variety of molecule like a 5-6 molecule or maybe a 10 molecule may exist, the developed sensor, it should be selectively sense only the target analyte even in the presence of other molecules. You can see these particular polyurethane have a very good activity towards anthracene compared to another molecules. So this is another class of materials, antibiotics. Even in the modern days, most of the like a cattle farm or maybe a chicken farm or other like a fish industry, like aquacultures, many antibiotics have been used for as a food and as a medicine. It will easily reach through the soil and water, and finally it will reach to the human body. So it will cause a various health issues. So hence it is highly essential to monitor these antibiotics. So for monitoring the antibiotics, the electrochemical sensor is a potential candidate for monitoring different kind of antibiotics. This is among the one for amoxicillin detections. Even in recent days, if you go for a doctor, in particularly the kids or maybe elder people, the doctor will prescribe at least 1 or 2 antibiotics to the maybe the person. The antibiotics, the total volume may be 100 ml or maybe a 60 ml. Most of the people, they will consume like maybe a 20 ml or maybe a less than 30 ml, and the 70 ml or maybe a 60 ml of the bottle will be like thrown to the environments, maybe a water or maybe a soil. It can easily reach to the water body, and it will again exist through the food to the human body cycles. So this is the one example of carbon-based material for monitoring these amoxicillins using various carbon materials. So these developed sensors shows excellent activity towards the particular like antibiotics. So this is another compounds called paraxanethyl. This comes under like a pesticides. It is also a contaminant. So to sense the level of pesticides here, they use like a palladium nanoparticles, which is prepared on the laboratory, which is loaded on this glassy carbon electrode, which will undergo the electrocatalytic reaction with this molecule, and it can end up with the levels what exist in the particular systems. So these developed sensor can also tested with the real molecules like vegetables as well as water. So it will works and it will end up with the very lowest detection limits. So this is another example for sensing of like a malathion. This is also pesticides. Like antibiotics and pesticides is occurs due to various agriculture activities. It is a highly the most dangerous contaminant, that is the environmental contaminant, which is need to be monitored very carefully. So for monitoring this, the electrochemical sensor is the best tool. So this is an example in the presence and absence of malathion. You can see this is a copper nanoparticle in the absence and the presence of this particular malathion. This from this current value, we can easily say the level of particular malathion on the taken samples. So in addition to this electrochemical or maybe a chemical sensor, it can also be used to sense various gas molecules like a carbon monoxide, carbon dioxide, or maybe a volatile organic carbon. So this is, I just want to give the overview how the formaldehyde concentration over the globe, which is taken from this site like BBC Science, which is published in 22 June 2018. So you can see the level parts per billion. So over our country, the value it shows a little higher than the remaining part, but this is not an entire picture. But the message, we need to monitor, we need to develop some kind of gas sensor to also monitor the gases which is exist in the environments. So these are all the some of the commercial gas sensor which is available in the market. If you want, you can purchase through India Mart. So the message I just want to convey, whatever the sensor, like a maybe a carbon, if you want to monitor carbon or maybe some other toxic gases, so it consists a sensing matrix which is have a nanomaterials like a oxide, metal oxides. Once the gas reaches its surface, based on the concentration, it will give the values in the display. So these are all the mechanism which is adopted in the gas sensor working counter and overall reactions. So maybe up to this, I can summarize the today talk of nanomaterial based sensor for monitoring healthcare and environments. The summary of this talk which consists the electrochemical sensor plays a vital role monitoring the environment as well as health of humans. So for this, the nanomaterial help to enhance the redox behavior of the particular analyte, and it can helps to go to the either maybe a nanomolar level or maybe a picomolar level. So the nano sensor, the as we discussed, the electrochemical based or maybe a chemical based nano sensor is a rapid, low cost and easy to access methodology. So with this, so I would like to thank all the audience as well as the management for providing the opportunity to discuss some of the findings, what is going on in our laboratory as well as the electrochemical sensor. If you have any queries, I'm very happy to answer. Thank you one and all.
Thank you, Doctor, for a wonderful session about regarding sensors, and these things are needed for engineers.
Yes, absolutely. So actually, we are, if you want to be say very frank, many engineering students nowadays working for the development of various sensor, like electronic engineering students, they are approaching us to develop, to help us for a miniaturization of this, like a portable sensor to handheld or maybe like a small a small smartphone sized one.
Yes, definitely.
So in addition to this engineering, many chemistry, like chemistry students, biotechnology students, physics background students, they are also focusing for development of various nanomaterials as well as like a enzyme and DNA, RNA, like that.
So, participant, any question to the speaker?
So in addition, anybody wants to do some kind of like a 3 months project or maybe a 6 months project, master degree, like a MSc, MTech. So we offer yearly 2 to 3 times, like every March and every November. So those maybe their students, they are really interested to learn something on the sensor development or maybe a device fabrication. It's always welcome. I just shared my phone number in the first slides. So those who are really interested, you are welcome for the interaction as well as like a collaborative work. Or if you want to send your students for learn something to learn material synthesis or maybe a device development or sensor development, you all always welcome.
So we given that digital movement to use for that. The
Sorry.
speaker.
Yes, yes. I think if there